Okay, so this is your warm-up for today. We'll pause the video here for you to try the 3 problems, and then we will unpause and you can watch me do the answers. All right, so for number 1, before we can take the derivative, we have to update the way the equation looks. And you can't have any radicals or exponents in the, variables in the denominator. So the square root of t is the same thing as t to the 1/2. So to move that out of the denominator, we're going to make it 7t to the negative 1/2. And then we'll make this t to the negative 4th. So the derivative, using the power rule, we get 18t, and 3 minus 1 is 2, so 18t squared. Bring that down, so minus 7 over 2t. Now negative 1/2 minus 1, so I'll do 1 in the form of 2 over 2 with a common denominator. That's negative 3 over 2. Then bring that down, so plus 4t to the negative 5. So then everything with a negative exponent has to go back to the denominator. And there's our final derivative answer. Okay, so for 2, we have those 2 functions. Let's find the sum. So I'm going to add the like terms. And then the derivative. So this is k of x. So the derivative is 6x plus 1. And now lastly for 3, when we want to write the equation of the tangent line, we'll use point-slope form, and this problem gives us everything we need. The derivative is our slope. The original function here is our y1, and x1 is 4. So we get y minus 7 equals 10, x minus 4. If you want to change it to slope-intercept form where the y is isolated, we can distribute the 10. And then add the 7. So y is also 10x minus 33. So this is a correct equation, and this is a correct equation. Okay, for number 1, you can skip C, because we won't do an x to the 3rd the long way. Let me make this bigger. So for A, f of x plus h, we're going to plug x plus h in for x, distribute the negative 3. So now I can write my limit. So it's f of x plus h, which we just found, minus f of x all over h. We have to distribute this negative. Notice I'm writing the limit every time. You have to write it until you plug in 0. Let's see if anything subtracts. Those go away. Those go away. We're left with the limit as h goes to 0 of negative 3h over h. The h's divide. Well, now there's no place to plug in there's no place to plug in 0, so our answer is negative 3. And now for B, we have to find f of x plus h. And just before I keep going, I know with our shortcut, our answer is going to be 6x plus 2. So I just want to write that so I make sure that's what we get to. X plus h squared is x squared plus 2xh plus h squared. I'm going to distribute the 2 here. And then lastly, we'll distribute this 3. Okay, so now we can do the limit. So we'll bring down that long polynomial. Minus the original function. We have to distribute this negative. So that's minus 3x squared minus 2x plus 1. So 3x squared minus 3x squared, 2x minus 2x, negative 1 plus 1. So let's see what we have left here. Everything in the numerator has an h term that we can factor out. So that leaves us with 6x plus 3h plus 2. These h's divide. Now we can plug in 0. And we get 6x plus 2, which is exactly what we expected. Okay, so for number 2, we're going to use the power rule. For a, the derivative is 3. For b, that's going to be 12x to the 11th. So the power rule is this exponent comes down to be the coefficient, and then subtract 1 from the exponent, we get 11. So this becomes 4/3 x to the, so we have to subtract 1, so that's 1/3. So for D, we get negative 3/4 x, so minus 1, it's going to be negative 7/4. Now, typically, if the problem starts with a negative exponent, you can leave a negative exponent in your answer. If it started with a positive exponent, we should change it. I'll just change it just to be safe. For the multiple choice, I'm not sure which way it would be typed. So this moves to the denominator with the 4. Okay, so for E, before we can take the derivative, we have to change that to an exponent of 1/4. So now the derivative is 1/4 x to the negative 3/4. So rewriting that, do that down here, that is 1/4 x to the 3/4. Okay, so now to do F through J. When you already have a coefficient, we're going to take the fraction, the exponent, and multiply it. So that is 12/2, which is 6. And then we have to subtract 1 from the exponent. That's 1/2. Then we'll get 5/2 x to the negative 1/2. So rewriting that, that is 6x to the 1/2 minus 5/2x to the 1/2. Okay, for G, we get negative 12x to the 3rd minus 12x squared minus 6. The derivative of a constant is 0, which is why it's not included. Okay, for H, let's see, that is 24x squared minus 8x plus 12. And now for I similar to the warm-up question, but before I can do anything, let me rewrite the original so that we only have positive exponents. Okay, so now the derivative is 15x to the fourth minus 5 over 2x to the negative 1/2 minus 7x to the negative 2. So that's 15x to the fourth. The x to the 1/2 comes back to the denominator. Same thing with the x squared. Because the problem started with the square root, I'm just going to rewrite this one more time as the square root of x, because this x to the 1/2 is the same thing as square root of x. Okay, now lastly for j, let me get rid of this. So we get x squared plus 1/2 x to the negative 1. Only this x is what has to change with the negative exponent. So now the derivative is 2x minus 1/2 x to the negative 2. So it's 2x minus 1 over 2x squared. Find the slope of the tangent line. Okay, so what we're going to do is find the derivative and then plug in that x value. So f prime of x is 3, f prime of 2, well, that's still 3. For b, f prime of x is negative 2, so when we plug in 3, we still get negative 2. The derivative in c is 2x. Okay, now we actually finally have an x to plug into. So that's 2 times negative 2, and we get negative 4. For d, f prime of x is 6x plus 1. Then we're going to plug in 1, so that is 7. And then for e, we get 5 minus 3x squared. Oh, I'm going to rewrite that. Okay. 5 minus 3x squared. We're going to plug in negative 3. So we get 5 minus 3 times 9. It's 5 minus 27, negative 22. All right, find the equation of the tangent line. So let me start. I need an x, and then we need the y. And we're going to get the y by plugging in the x here. So 2 times 5 is 10, minus 3 is 7. We're going to get our slope from the derivative. So the slope, f prime of x is 2. Well, when you plug in 5, the slope's still going to be 2, so we get y minus 7 equals 2 times x minus 5. If you want, you can distribute that 2 and add the 7, and that's also a correct answer. Okay, so my xy point is going to be 2, 4. You'll always use the original function to get the y value. Our derivative is 2x, so f prime of 2 is 2 times 2, which is 4. So our equation is going to be y minus this 4 equals slope x minus 2. Okay, for c, our point is 0, 0. F prime of x is 3x squared. So when I plug in 0 to the derivative, we get 0. If you want to write it all out, that's going to be y minus 0 equals 0 times x minus 0, which really is just y equals 0, because this all is 0. That's a pretty boring question. Okay, for d, now I'll actually get some values. When we plug in 0 to the original here, we get negative 6. F prime of x is our slope. We're going to plug in 0 to that. We get 1. So y minus negative 6 equals slope x minus 0. So that's y plus 6 equals x. So let's subtract the 6 over. All right, last but not least for E, we have the point 0.04. Plug in 0 here and here, we're left with 4. Our slope is 4x to the third minus 10x. When we plug in 0 for that, we'll get 0. So y minus 4 equals 0 times x minus 0. So y equals 4. Okay, fill in the blanks. If the original graph is increasing, that means the derivative is positive. You could also say greater than, not equal, just greater than. If the original is decreasing, it means the slope is negative or less than 0. If the original is constant, that means the slope is equal to 0. The derivative of a line is always constant. The derivative of a quadratic will be linear, because if you think the y prime, that's going to get us 2x plus 5. That's a linear function. A cubic, the derivative of a cubic is always quadratic. And the derivative of x to the fourth is always cubic. That works because each time you take the derivative, you reduce your exponent by 1. So the cubic becomes quadratic, the quartic, or the x to the fourth becomes cubic. Okay, sketch the derivative. Let me find y prime. All right, so that's going to be a horizontal line here at -2. I can't do that for 9. Let me graph the original for 9. You could use your calculator to graph that. And this is a positive slope of 1, and this is a negative slope of 1. And at -2, there is no derivative because it's a sharp point. There was a slope of positive 1 and a slope of -1. Okay, so for 10, y prime is 2x. So if I find a table of values, when we plug in -2 here, we get -4, plug in -1. So if we plot those points, and then connect your dots. All right, we need point slope form. This is x1. The derivative is your slope, and this value is y1. Okay, find the slope of the tangent line when x is -1. So first we need the derivative. Oh, well, the slope is going to be 3 everywhere, so the answer is 3. Okay, for 13, you can use the draw tangent on your calculator. Since it's a rational function, if you graph that, 4 over x looks like this, approximately. And you want the tangent line at x equals -2, like that. And the calculator will give you the answer. I don't have a calculator, obviously, so I'm going to do it by hand. So the derivative is -4 over x squared. Plug in -2. So that's the slope of -1. The point -2 is going to have a y value of, if I plug that in here, also -2. So we get y minus -2 equals m, x minus -2. So you really don't need the calculator. You could definitely get it, use a calculator for your graph, but finding the equation is not bad without a calculator. Okay, it says use the derivative. So first I have to find the derivative. Determine any points, so that's x comma y, where the tangent line is horizontal. That means a slope of 0. So we'll set the derivative equal to 0. Let's solve this. We can factor out a 3x. Set each factor to 0. So x is 0 and x is negative 2. But the problem wants points. So we need y values. We are going to get these y values from the original function. So, you can see what it was. When you plug in 0, we're going to get 0. When we plug in negative 2, you can use your calculator to plug them in if you want. Let's see what we get. It says negative 8 plus 3 times 4, so that is 4.